Hello, and welcome back to another video with It's Dr. Dan, and we're going to continue looking at math skills to ace chemistry. And today we're going to be looking at unit conversions, which is arguably the most important math skill that you need to pass chemistry in general. And that's not to scare you, but that's being that it is a part of our labs, it's a part of almost every single chapter that you'll come across in chem. So when it comes to studying this, you really want to make sure you take the time and practice as many problems as possible. But let's talk about exactly what this has entail. So with this, the first thing is there's a couple key little definitions. One is dimensional analysis, which is a term that gets thrown around quite often within your first few weeks of chemistry. And what this is a mathematical method used to convert measured units. And it's that keyword measured, which keeps getting brought up, right? You're in a lab, you're taking measurements, masses, volumes, length, time, temperature. You will be converting them to different things that will help illustrate the meaning of your reactions. So you need these to answer problems. So you're going to continuously see that from time again. So when you're doing unit conversions, the key thing is that you're going to be using conversion factors, which are ratios or relationships between defined units. So one really easy example of that is if you think of a foot, right? And I ask you how many inches are in a foot. Well, for all my American people out there, right, you can think 12 inches is 1 foot. Or if I ask you how many centimeters is in 1 meter? Well, 100 centimeters is 1 meter. Those are defined terms. Or if you ask how many pennies are in a dollar, right? 100 pennies are in $1, another conversion term. So look at the basic ideas of just using our algebra. So what you learned a really long time ago, maybe in grade school or high school, starting with fractions. So how do fractions work? Well, if I kind of set up the following problem, and let's say I want to know if I have 2 over 7 and I times that by 3 over 2. Well, you can do your you can rip out a calculator and you could calculate this and easily solve it. However, we can simplify this problem by just doing some little cancellation. When it came to fractions, when you have the same units or numbers, they cancel when they are opposite of each other. So in this particular example, you can see that the 2's are opposite and they are the same. So they can cancel and simplify. So each 2 will cancel and simplify down to 1. So if I do the math here where I multiply across, right, we can see that we have 1 times 3, and then on the bottom we have 7 times 1. So we can get our simplified answer. So when you are doing units, it's going to be a similar idea. So let's look at this in an analogy for ourselves. What exactly does unit conversion mean? So if I have the following little picture, let's say I have 3 little creatures here and they all speak different languages. So if I have the first one and he only speaks Spanish, so he speaks Spanish. However, he wants to speak to the bird, which the bird only speaks French. So how can they communicate to each other? Well, if you kind of think in our everyday lives, if we have someone who cannot speak the same language, well, what do? You have a translator. You have someone that can interpret that. So we find another bunny in the middle with a little thumbs up, and we find out that, oh, they speak French, and they also speak Spanish as well. So what are they going to do? They're going to help translate that conversation between all these little creatures. So when we have that, we can set this up like a fraction problem. So how would you do that? Well, if I have my first bunny that is Spanish, and I multiply that by my second one, which is a fraction, right? So we have Spanish, which is our given, and French, which is our desired. One thing you'll notice is that Spanish cancels out Spanish, and that only equals French. So it is also a mathematical problem. Now, the thing about that is there's an easier way to show this rather than just fractions. We're going to be using something called t-tables, which help us illustrate these types of problems. So when we do this, we'll set up a little table like this where every single one where we have a line across, which represents our problem. So if I have the first one, which was Spanish, I would insert my little parts of the problem. So French, Spanish, and then we can see that, oh, this cancels our units, giving us our one little piece. So we're going to go through unit conversions and do several problems and examples through this. So why don't we check it out as we go forward of how we can use unit conversions in chemistry. Okay, so with this next one, so suppose a model car measures to be 15 centimeters long. How many inches is that? So you can try to Google that, right? You can see how many centimeters are an inch, but how do you set up a problem? How do you go through it? So when you have problems like these, the first thing you're going to do is you're going to highlight and determine all the important piece of information. So we see that we have a 15 centimeter object, and we want to know how many inches is this going to be. So when we do this, we write down what our given pieces of information are, which we can see, okay, well, we have 15 centimeters is one thing, and we desire it to be in inches, right? We are in the US, so we want it to be in the US system, but we need to be able to communicate effectively with metric system because it is a global system. So how do you go about that? So we need to define what that conversion is to go from one unit to another. So when you are doing these types of things, most likely you will have a conversion sheet available to you. If you do, well, we can look up how many centimeters there are in an inch. And when you do, you'll see that there's 2.54 centimeters in 1 inch. And if you want to take that time, you can pause the video and try to find that before just going off my word. So when you have that relationship, right, that they are equivalent to one another, we can illustrate that as that they're equal. But they are also representative of ratios or fractions. So when we do that, we can say, okay, 2.54 centimeters is equivalent to 1 inch, or we can write it as the reverse or the flipped version of that, where 1 inch is equivalent to 2.54 centimeters. Now, when we do these problems, I'm going to color code these, we have to let the units guide our thinking. So let units guide you, meaning that we have to let them show us how we are going to be canceling these different problems. So going back to our translator problem, right? When it came to Spanish and Spanish, they were opposite. So they canceled. In this case, right, we have centimeters on top. So centimeters needs to cancel here as well. So if we look at our two where we have purple and yellow, well, the yellow one has it where centimeters is on bottom. So we can see that, oh, centimeters cancel centimeters. They're both going to cancel, leaving us with only inches as a result. So that's our final unit. So we can go through and calculate that. So when we do the math for that, we can see 15 divided by 2.54, and we will get that we will have 5.9 centimeters as our final answer. Or sorry, not 5.9 centimeters, 5.9 inches as our final answer. Okay, we'll box that off. And that's how you go through a basic conversion. Let's look further into this. Let's try to understand how these conversions come about. So when you are understanding conversions in lab, it's all based on the International System of Units, or SI units. You'll commonly hear your professor mention that word. This is the preferred method of measurement. The reason for that is because it's not just for chemistry, but it's for your entire scientific community. And for many of you that watch this channel, you're interested in the global health community. So whether you want to be a nurse or maybe a dental hygienist or some sort of caregiver, we commonly are talking in the metric system because it is applicable to the entire world. So what we are looking at is most of these measurements refer directly to a base unit. So that is our measurement. So some types of base units that you will see very commonly are like for length are meters, mass are kilograms, right? So we're used to maybe more like pounds, but kilograms is an easier unit to work with. Volumes, so liters, Kelvin is temperature, seconds, time. or moles. In future videos, we'll see a lot of moles. We deal with a lot of these, and these are our different base units. Now, these are the standard for how we look at them. Now, all these individual base units can be edited with a prefix. So being that all the base units, they operate on a 10 base scale. So meaning in order to simplify the mathematics, we can put a prefix in front of it to make it a smaller or a larger number to make it easier to handle. So that way we're not always dealing with these ridiculously sized numbers all the time. It depends on what are you talking about. Are we referring to chemistry, bio, physics? Every one of them has their own scale. So when it comes to prefixes, they have a base unit multiplier, meaning, let's say if I have liters, for example, I could say that I have 10 to the 9 liters, which is equivalent to 1 gigaliter, which would be the first prefix on this list. Now, being there are so many mnemonics, and we'll refer back to this, we'll refer back to the list over here, right? You should and try to remember these. I would recommend heavily to put these on flashcards for yourself, being that you will probably need them at some point. So when you are trying to learn and figure all these out, there is a simple mnemonic for it, which is to try to remember all these. So I'll read the prefixes first. So when you are starting these, we start from the top, which is giga, mega, kilo, hecto, deca, then your base unit, deci, centi, milli, micro, and nano. Now there is a prefix, a little mnemonic. So if you remember, the great mighty King Henry died by drinking chocolate or chunky milk Monday night, and you can kind of remember a little image with that. It'll help you remember all your prefixes. So mnemonics are very, very helpful when it comes to these. So if you remember that the great mighty King Henry died drinking chunky milk on Monday night, it will help you remember your prefixes. Now the values for that will come with practice. The more you practice it, the easier it will get. So let's work on trying to define those. How can we write them as a unit conversion like we practiced before? So let's do some normal ones. If I asked you, all right, well, if I have 1 liter, how many milliliters are there? Okay, so what we could do is we would look up our milli prefix and we'd look across and we can see, all right, well, the base unit multiplier is 1. That's referring directly to liters. So as we are showing here, right, we have 1 liter, and let's use a bigger font size here. So if I have 1 liter, that's going to be equivalent to 1,000 milliliters. And we can see that 10 to the 3. The 3 power, so 10 to the 3, is referring to the 3 zeros that are here. So just as a reminder. We can show this in many different ways. We can define it as a fraction, right? We can say 1,000 milliliters is 1 liter. Or we can flip it and say 1 liter is 1,000 milliliters. We can do others. If I have, let's say, one of the larger ones, let's say if we do kilo. So up here, you can notice that the base multiplier now all of a sudden has a value to it. So the base unit multiplier is 10 to the 3. So if I ask you, how many grams are there in a kilogram? We could do that. So if I have 1 kilogram, we could see that on the right-hand side right here, right? 1 kilogram. And that's going to be equal to 10 to the 3 grams. That's 1,000 grams. And we can go through and define that ratio as well. So if I wanted to, I could write, all right, 1,000 grams is equal to 1 kilogram, or 1 kilogram is equal to 1,000 grams. And the way to really look at this table is everything on the top is big, everything on the bottom is tiny. And that's in respect to the base unit. So the base unit is really small on the top and it's really, really big on the bottom. So that's kind of the idea here, is how many of them does it require to make that thing. Now, let's try to do some examples of that and try to practice it for ourselves. So if I have the first one here, it says convert 22.4 liters to milliliters. So what you would have to do is go to your tables. Now we defined this one before. So we said that 1 liter is equal to 1,000 milliliters. So let's do this problem. Let's go through our steps. First thing you're going to do is write down what is given. First thing we have is we have 22.4 liters, and we also have the conversion term from before, which was 1 liter is 1,000 mLs, or 1 liter is 1,000 mLs on the flip side, right? And what we desire is that we want to find mLs, okay? So let's set this up as a table for ourselves. So what we're going to do is we're going to write our little line, and we're going to show our T table. We will start with the 22.4 liters. And what we have to do is, you remember the tip from before, let the units guide you. So if we let the units guide you, how do we cancel out liters? Which one can I use? Do I use the one on the left or the one on the right when it comes to these conversions? And the thing you will see is that, well, if I use the one on the right here, well, liters will cancel liters because they are opposite of each other, right? They are opposite. So, and that's the big idea. If they are opposite, they will cancel. So we have the 1,000 mLs on top, 1 liter on the bottom. And then we can show, okay, liters cancels liters. They both go away. And it leaves us only with milliliters. So when we do this problem, we will see that we will get an answer of 22,400 milliliters. And if you want some practice with scientific notation, it's a good time to do it because we should be practicing all of our skills. So we can see, all right, if I want to put this in scientific notation, I got to move that decimal place 4 times. So it's going to be 2.24 times 10 to the 4th milliliters. Both answers would be correct in this case. It just depends on really what's more convenient for you and your situation. Let's do another. So for this next one, if you want to convert 3.4 milligrams to kilograms, how can you do that? Well, first, what we're going to do is we write down our given, right? We have that 3.4 milligrams. We desire to go to kilograms. So what we need to do is write down all conversion terms that are relevant. Now I picked this one on purpose because there is a bigger prefix gap here. Let's slide up to the prefixes. For this particular problem, we are going from milli to kilo, just like earlier, meaning that there is a large gap between these two areas that we can see. Whenever there's a gap, whether it's from one prefix to a lower one or to a higher, one good strategy is split it up into 2 steps. And why would you do that? Is because all of these modifiers that we see are all in respect to the base unit that I have here in yellow. So meaning the first do one conversion to the base unit and then do a second conversion out to the number that you desire. So let's write them both down and I'll show you in this example. So we're going to write it down for milli and from the base unit to kilo. So let's do that. So what we have is we have 1,000 milligrams is 1 gram. So we'll write that down. And then we also have that 1,000 grams is 1 kilogram. So from our choices, what we are going to do is determine how to start this problem, because we have 4 different puzzle pieces that we can choose from, right? We have this one. I'll try to use different colors. We have this one. We have purple, yellow, red, and blue. Oh, that is not blue. And blue. So we have all these choices. So if I start with my first part, which is my milligrams, and I'll put that in my table. How would I cancel my units? So let the units guide you. So first, cancel milligrams. So we need milligrams to be opposite of our milligrams. So looking at my pieces, we can see the yellow one above is the one that fits the best. So let's put that here, right? You can see mg is opposite of mg. These cancel. And then our units are now grams as a result. Now, are we finished our problem? And the answer is no, right? We want to get the kilograms. So how do we let the units guide us? Well, grams now need to get canceled. So when we kind of do that, right, grams need to be opposite of grams. And we can now see, well, okay, the purple piece now cancels our, or sorry, purple. The blue piece cancels our units for grams to kilograms, right? So 1,000 grams is 1 kilogram, which as a result, and you can check yourself, is that this leaves us with the units that we desire, right? We want kilograms, so put a little check next to it to double check ourselves, because you can see that even I made a small mistake there, which is really normal, right? It's easy to get a little mixed up. So when we do this problem, you multiply everything on top, divide all the things on the bottom. Or if you want, you can also remember that each one of these little line sections here, so this part or here, these are all fractions, so you can always set them up in your calculator like a fraction as well. So if I do this, right, I have 3.4 times 1 divided by 1,000 divided by 1,000. So when we do that, our final answer, it's going to be a very tiny number. So I'm going to put in scientific notation first, and this is in kilograms. So it's 3.4 times 10 to the negative 6 kilograms, or 0.0000034 kilograms. So it's a very small number that you can choose for your answer. Personally, I'm a bigger fan of scientific notation, but if you're new to chem, usually everybody goes for the other option for a little while until you're comfortable. All right, so now for our very last note before we sign off for this video on unit conversions. You'll also have to do unit conversions for US to metric as well. The only big difference about this versus with SI units is that US units and metrics, they are their own systems. So meaning that if you have to do a US to metric conversion, these are all measured. So meaning that we have a specific measurement for each of these, and they all came up with their own unique method of how they came about. So when you use them, you have to consider significant figures in the calculation. So with most of these conversions before, the number that you were given at the very beginning was how many sig figs you needed at the end of the problem. However, if you use a US conversion, you can kind of see in these that all of these values, they have the measured terms in it, which actually have the decimal points in them. They can affect your calculation. So if you choose to use one with more decimal places or significant digits. So that way it does not affect your rounding in the end. So use one with more values. So keep that in mind when you are doing future calculations as you are going through these. I hope that this video helped you. There will be two new videos coming out very soon. One will be a follow-up to this one in terms of some extra practice problems for this, which are harder problems. So they'll be going through US to metric conversions. So doing an example of that, doing cubed volumes. So using things that are like cm cubed, and then doing a multi-step unit conversion. The other video, which should come out within the next few days, is on dimensional analysis. And by the time some people watch this, it'll be already out for a long time. But dimensional analysis, more specifically on word problems and how to decipher them. So please stay tuned for those videos. Please like and subscribe and tell me what you think about them. Tell me if there's anything you would love a video on to help you pass your chemistry class. I will try to make that as soon as I can. All right, thank you so much. This has been Dr. Dan, and I will see you all soon and see you next time. Bye now.